In this video, we're going to quickly look at ions and subatomic particles. So here I've got some Bohr diagrams of a sodium atom, and up on the top here I've got a fluorine atom. Now, these will become ions, and what's going to happen is that they want to have a full valence shell or an outer shell. We often refer to it as an octet. And you can see here that I am missing an electron. If I had an electron there, fluorine would have a full octet. Whereas sodium atom, which has the 2 electrons on its inner shell, and then it's got 10 electrons on the next inner shell, then in its valence shell it only has 1. Well, we would like to move this away from the sodium, and if it could go up here to the fluorine, it would leave fluorine with this extra electron, and it'll have 9 protons, 10 electrons, and it'll have a 1 negative charge. So it's a fluoride ion. And this negative charge comes from having the extra electron. Whereas sodium, when it gives away that electron, it then has a full octet as well. And now this has 11 protons, but it only has 10 electrons, so it has a 1 positive charge. So the sodium ion is an Na positive charge. Now, we're going to take a look at this table and see how we can fill this in. So the chloride ion has a 1 negative charge, and it's got 17 protons. The 17 protons come from the atomic number for chlorine. So the 17 protons is here. Chloride ion has a 1 negative charge, so it accepted 1 electron, and it ends up with 18 electrons. So it'd have 17 protons, 18 electrons, for a total of 1 negative charge. Whereas atoms are uncharged. So if we were looking at our sodium atom, sodium has 11 protons because that's its atomic number. Because it has 0 charge, it's an atom, and it's got 11 protons, it must also have 11 electrons. As 0 electrons are gained or lost, and it has a net charge of 0. So once we've got that pattern and kind of way of thinking, we need to see what we've been given for information and do a little problem solving. So here we have 20 protons. Protons are always the atomic number. So if the atomic number is 20, I know that that is calcium. This is going to be calcium. But here we have 18 electrons. So if I have 20 protons and 18 electrons, electrons are negative, I've got 2 more positives than negatives. So this is going to have a 2 positive charge. This will be Ca2 positive, and this is a calcium ion. Now the name for calcium ion is listed here along with its charge. Now, if it was an atom, atoms have 0 charge. So it would also have 20 electrons. But the ion, the calcium ion, had the 20 protons, and it only had 18 electrons to give it a 2 positive charge. So it must have donated 2 electrons, right? It had to give those away to get that positive charge. Here, we've got one proton, and I can go up here and I can see that one proton is hydrogen. Now, hydrogen in this case has a 1 negative charge, and so hydrogen is listed twice here, and it's called a hydride ion when it's a 1 negative charge. This is not my favorite example. Hydride ions are very uncommon. The symbol is H negative, and if it has one proton and it has a 1 negative charge, so it has one positive and a 1 negative charge, then it must have 2 electrons to be able to get that 1 negative charge. So it's got 2 electrons, and it must have accepted 1 electron. Because a hydrogen atom would have been 1 proton and 1 electron for 0 charge. If it has 2 electrons, it must have accepted 1. Now, argon is on the periodic table, and we got to scan and look around. Argon happens to be a noble gas, and it's up here. It has 18 protons. So this is an argon. Argon is always going to be an atom. So this is an argon atom. It's a noble gas. So all of the chemicals in this group over there in group 18 are noble gases, and they have 0 charge. They'll always be atoms. So this is 18 protons. If it has 0 charge and it had 18 protons, it must also have 18 electrons. And so there are none gained or lost. The next one is a magnesium, and you can see in the symbol here that there's no charge. So this is going to be a magnesium atom. It has 0 charge. So if it has 0 charge and it had 12 protons, it must have 12 negative electrons. It'll have no electrons or no electrons gained or lost. A chlorine atom. Chlorine is over here. It has 17 protons. And so the chlorine atom is going to have 17 protons. It's Cl, but it doesn't have a positive or a negative because it is an atom, not the ion. So it'll have the same number of protons and electrons. There'll be 0 transferred, and it'll have 0 net charge. So we've got 2 more examples to show here. If there are 9 protons, then that means that it is the fluorine atom or ion. It has 9 protons, but it has 10 electrons. So you're going to have 9 positives and 10 negatives. I have 1 more negative than positive. So this is going to be 1 negative charge. It gained 1 because it's going to be a negative charge. This is F negative, and this is called a fluoride ion. And if you weren't sure about the name of it, let's go back here and see that when fluoride has a 1 negative, that's listed in your periodic table. The last one has 6 protons and 0 charge. If it has 0 charge, I know it's an atom. If it's 6, I know it's carbon. So this is a carbon atom. It'll be C, no positive or negative because it's an atom. It'll have the same number of electrons as protons, and it'll have 0 that are transferred. So you can follow that sort of logic and thinking as you fill in this table.